So here's a picture of a golf hole on the way to Whistler at Furry Creek. It's on the water side as you drive from West Vancouver. And if you look at this shot right here, it's actually a par three. And according to this little picture, you have two choices. You can hit a smaller shot and then hit a shot to the green, or you can try to whack it right on the green. So given this story right here, the question is it possible for him to hit the green, given that he can hit his 3-iron between 170 and 200 yards? So what do you think? Pause the video for a sec, think a little bit, and see what you come up with. Okay, so one of the things we have to do here, because there's no scale, we actually have to imagine what might happen. So if you imagined he hit a straight shot right at the green, 160 yards in this story, where might that land? And then you'd have to imagine where might 170 be and where might 190 be. So if I were going to try to imagine where 160 yards would be, I'd imagine it would be about right there. Now again, I'm just eyeballing it. And now what I'm going to have to figure out is, I'm going to have to figure out what's that distance right there. And again, what I hope you see is there's a lot of, I'm going to have to imagine, I'm going to have to try to figure it out. So it's pretty hard to answer this question as it looks. So let me just summarize that in words. And maybe you're thinking the same thing. So it is difficult to tell, given we can only imagine, just like I was just talking about, we can only imagine distance, as there's no scale in this picture. So we can't measure it. We can't imagine or get a ruler out and go, well, this represents 160, so therefore we can try to represent the rest of the distance. What we can imagine is, as I put the red dot, we can imagine 160 yards is straight at the green. And that's that little red dot that I put on earlier. But the remaining, 10 to 30 yards, because remember, he can hit it 170 to 190, would be more difficult to imagine. So if this were a 90-degree triangle, we could actually use Pythagorean theorem, and we could do it that way. But it's not a 90-degree triangle. So then that leads into the question, we just finished a unit on trigonometry of non-right triangles. What kind of triangle do we have here? So in this question, what I'm asking is, if you connected this thing to this thing right here, if it was a straight shot, which is the shortest distance, right? What kind of triangle do we just draw? And what it's called is, it's called an obtuse triangle. And an obtuse triangle is a triangle with one angle with an angle greater than 90 degrees. A triangle with one angle greater than 90 degrees. And in this one, you see the 110, greater than 90 degrees. And that's very different from what we've been looking at, because we've been looking at acute triangles. And acute triangles have all angles less than 90 degrees. Acute triangles have all angles less than 90 degrees. So these are different, just like acute triangles were different than right triangles. So here's what I'd like you to do. Get out your calculator and just punch in cosine of 0, cosine of 15, cosine of 30, sine of 0, sine of 15, sine of 30, etc. And put your answers to 4 decimal places. Now, this other one right here, we won't fill. In your notes, you're not going to have this column anyway, so let's not use those two. And go ahead and do that, and I'm going to fill it in. Okay, so here's the most important question, given that you've filled this in. Again, I'll make my notes match your notes, so we don't care about tangent. So what do you notice, especially with respect to these last two columns? And what you should see is, with respect to cosine ratios, the number our calculator gives for the cosine, what you want to notice is these numbers start at 1 and they go to -1. And the other thing that's really important to notice is, all angles greater than 90 degrees are negative. So that's interesting, something interesting about cosine. If you look at the sine column, they're not negative. And the other thing you want to notice, angles match, but they're not equal to each other by match. I mean, one is positive, one is negative. So they're actually opposites, right? Angles match, but opposite, but negative. And if you look at, for example, 15 and 165, or 60 degrees and 120. So those are some things to notice with the cosine law. And if you've noticed those yourself, then that's a lot better than me telling you. And well, what about the sine? And again, if you want to pause the video for a second, see what you see with sine. Now, there's other things in there, but these are the only things I'm going to worry about. So for the sine, the ratio starts with 0, and it goes to 1, and then it goes back to 0. And it is always positive. The ratios are always positive, unlike the cosine ratio, where we get some negatives. And the other thing you might notice is some numbers match, angles match. So for example, the sine of 15 degrees is equal to the sine of 165 degrees, and the sine of 60 degrees is equal to the sine of 120 degrees. So that's kind of interesting. And then finally then, based on what we've just looked at, we can make two general rules that just a simple fact that I'd like you to know. The first one is the cosine. The cosine of an angle less than 90 degrees is equal to the negative of the cosine of an angle 180 minus the angle that we talked about. So for example, cosine of 15 degrees is equal to the cosine of 180 minus 15, which is 165. So we can make a general rule. The cosine of angle A is equal to the negative of the cosine of 180 minus A. Similarly with the sine of an angle less than 90 degrees is equal to the sine of an angle 180 degrees minus that angle. So the sine of 60 is equal to the sine of 180 minus 60, which is 120. And again, we can write a shortcut for that. So here's two little formulas, if you want, that are important. This one's a tricky one. The sine one's tricky. The cosine is very obvious.